Lakshmi completes her talk, so we'll move on to, we have our guest, Nishant Saxena with us from Dell EMC. He'll be delivering his talk as well in the same topic. And after that, we are opening up the forum to the panel discussion, which I'll be moderating. So hence I request the audience to post their questions in the Q&A box. We are compiling, and the panel will be answering your questions. So Aarti, over to you.
Okay, thank you, ma'am. Is everybody able to see my PPT?
Yes, we can see, yes.
Okay, so good evening, everyone. So topic for my presentation today is data engineering, the bedrock of data science. And this is the rough agenda. I just put points together so that I don't speak a lot and, keep myself on the track. So, I'm just going to talk about Modak Analytics, of course, talk about data engineering. And as Ms. Lakshmi rightly said, I'm also going to give you a perspective as to young talent like you all, where they can start their careers, their journey in a deep tech company like ours, or pretty much any tech company. Yeah, so this is our rough agenda. So talking about Modak Analytics, I mean, Mrs. Lakshmi has rightly said, but I'll just kind of give you more ideas to what we do at Modak Analytics. So we are a boutique firm based out of Hyderabad, and we primarily work in the data engineering space. Right, so we help our clients or big enterprise build huge data lakes or the data infrastructure. Usually the data infrastructure that we build for our clients run into petabytes. So there are huge, humongous data lakes. We also and we do that by building automated data preparations, by building automated data pipeline, ingesting the data, curating the data. And obviously, then we have the semantic layer where we also run data analytics and kind of glean insight into the data, right? So, and then in this space, we also have our few of the products, but one of the flagship product of ours is Nabu, which essentially plays around into the augmented data preparation space. Right. So this is essentially what we do at Modak Analytics. Also, I want to put through, like, in a client or in an enterprise, there are so many data lakes. Different data lakes, different businesses. Obviously, it's not possible to kind of ingest or have the data all together on one infrastructure, on one platform. So in an enterprise, there are a lot of data lakes, a lot of big platforms. So we also help our client enterprises build a seamless data fabric across all the data platforms so that the data is consumed by the business user or the end user seamlessly. Right, so this is essentially what we do at Modak, and I'll talk more about the data engineering prospect. Right, so why are we here today? Like Mr. Dheer rightly said, data has been there forever. I mean, it's been there for a long time. But what the difference is, the data is growing at an unprecedented rate. I mean, in 2010, the size of the whole digital universe was 1 zettabyte, and by 2025, it is expected to grow to 175 zettabytes. Right, so just to give you guys a perspective, 1 zettabyte is 1 million terabytes, right? And my thing is, by the time we reach the 2025, we probably have to kind of recalibrate this number as well, because data is growing at unprecedented rate. Right? And most of this data, by the way, that is generated across universe is 80% of that is going to be unstructured data. And one more data point or one more prediction is, 50% of the data that is generated in this digital universe is going to be on cloud. Right, so most of the CEOs and CXO levels understand the importance of data, and that they want to kind of invest heavily in the data infrastructure and the information data platforms so that they can derive insights from the data for better decision making, right? So they know the importance of data, all the CEO or the CXO levels. So, in a few years back, there was a adage that, data is the new oil. But I would say oil is a commodity, right? And the commodity doesn't grow, whereas a data it's growing within the organization, outside the organization. Data is growing as we speak. So essentially, so is its value. The data value is also increasing. So essentially, it is not a commodity, but it is a very, very important asset. And I think CEOs across the corporate kind of know the importance of data now. And that's the reason, if you, a few years back, or, 5, 10 years back, there's a new role, C-level role that has come up, which is called as CDO, Chief Data Officer. So one of the KPIs of a CDO is, he understands the business focus, he understands the business strategy, but then he also understands the data and how he can unlock the data within the organization to support the business strategy. So that is essentially the role of a CDO. So the industry, the enterprise has come up with a new role because they understand the importance of data nowadays, right? And so that's the reason CEOs are investing heavily into data infrastructure. Now, if they are investing in data infrastructure, obviously they're investing in data talent as well. Right. So, right now I'm at a symposium of demystifying data science, and I'm here to demystify one more thing. Even though the data scientist is the most glitzy job title that you can have in today's world, but look at the job trends that US has. I have just pulled this data from the top trends in the US, and where do you see data science? It's a lot below than the data engineer. So which is the hottest job? It's not the data scientist. It is the data engineer job, right? And then it is growing on. If you see the year-on-year growth, the data engineer's profile, job titles, what the enterprise need or the industry needs, have grown year-on-year at 88%, whereas the data scientist is only grown at 49%. So what essentially I'm telling you is, data science engineer is the hottest job. And why would that be? That is because, any data scientist spends 80% of their time in data preparation, right? And it is very different than the Kaggle competition that you go, where you get the cleanse and a very small data set, well prepared for you guys so that you can run your algorithms and can kind of find a lift from the data. But the real life scenario or the real life in an enterprise, it is very different. You do not have that cleansed data ready-made. So most of the time, the data scientists spend on 80% of their time is kind of preparing the data, and that's what the kind of the chart shows, right? 60% of their time is spent on cleaning and organizing the data, 19% collecting the data, and I look at the number in refining the algorithms. It's only 4%. So which algorithm to use and what not to use, 4% of the time is only used in that, but 80% of that time is used in data preparation, really, in any of the data analytics project or in the enterprise level. So what essentially I'm getting to is, the data preparation is the biggest hindrance for any data analytics project or any data science project, right? That's what the industry says, and that's what is happening in the industry. So you would be shocked to look at some of the statistics that I'm displaying on the screen. That says 60 to 85% of the big data projects fail to deliver business value. That's a huge number. I agree. It's a huge number. And, it's absolutely flabbergasting to look at this number. But what really happens is, these enterprises start enthusiastically. They invest heavily into the infrastructure. They spend time on POC, but they're not able to kind of go beyond the POC. Right, because they spend so much time in the POC with the data quality that they have at the organization level, and a lot of resources, time, money is spent at the POC level, and the business kind of doesn't kind of get the business value out of it, and the POCs are abandoned there itself, and it doesn't go ahead. Even if they get past the POC level, and say they collate everything, the whole data together. One of the vision that they start with is, we are going to create this whole big data infrastructure at an organization level, and then we are going to solve pretty much 50, 60 business use case or the business problems that the business has, right? So they start enthusiastically with that, ingest some data on it, do data analytics, but eventually, after a couple of years, they're only able to kind of answer one or two business cases. The reason being data preparation is very, very tough. It's very hard job, right? So that's the reason, they spend 2-3 years on just preparing the data and, finding the insight, but then they are not able to get past those 2-3 business cases, right? And that's the reason they fail to deliver the business value. The third example I would like to give is yes, they start, let's not go department wise. Let's just ingest the whole data get the whole data onto a data platform. Yes, well, you can do that. They get the whole data onto the data platform, essentially a data lake. And, without proper governance, without proper data lineage, essentially, it creates a data swarm, which is an ungoverned data lake, because you do not know which data is stale, which is to be used, where the data came from, where is the data lying, what do you do with the data, whose data it is, etc. So essentially, what it creates is a data swarm. And what happens is, whatever the problem that they had with the data at the organization level, now only thing they have done is they have replicated it on a data lake. And hence, it's very difficult to kind of derive value, business value from the whole kind of project. That's the reason 60 to 85% of data analytics or data science project kind of fail, right? So that's the statistic. So coming back to the 80-20 rule, right, where the data scientists spend 80% time on data preparation and only 20% time on gaining insight. Now, if you look at the world, for some reason, the whole world is pretty much concentrating on the 20% part, right? But the real problem at the enterprise level is the data preparation, or that 80% part, because it's very difficult and it's not easy to kind of do that, prepare the data before you kind of apply data analytics or ML or AI and stuff like that. And one of the things that we have noticed, even though they prepare the data and everything is ready, there are very few cases where you have to really apply ML or AI onto the data. Most of the business cases or most of the business problems given are exploratory. It's kind of retrospective in nature, where they are just trying to see what are the trends of the commodity or what the product sell, etc. So it's more retrospective in nature. And other thing that we have found is a lot of times the problems are not well defined. If you kind of collate the data and give it to the citizen data scientist, they want to explore the data and see what the data points that the data itself can give, right? As I said before, the data preparation is the main problem. Now, how do we solve this data preparation problem that the enterprise is facing? So one of the things that the industry has come up with, a concept called as augmented data preparation. So what essentially it means is you're applying machine learning and automation at the data preparation level itself, not only on the insight phase, but also on the machine learning and automation phase. So what does augmented data preparation capability really mean? That means you are having data spider to kind of spawn all the data sources and see where all the data is kind of sitting in silos. So you spawn data spider. Once you spawn data spider, you kind of collect the metadata onto the ingestion layer. Once the metadata is kind of collected, you kind of automatically generate automated data pipelines to ingest the data onto the platform. And once you create automated data pipelines, you can kind of refresh the data as many times as you want, because it's just it's called data ops. You pretty much are kind of running the data pipelines on and off as you need. So the other concept is automated data pipeline. The third one is, data tagging. Like, you automatically tag the data. What does the data say? Like, for example, if the column values are male and female, so obviously it is talking about gender. So you tag the data across the whole infrastructure. Right, and that is done using fingerprinting. And why is this important? Because in Kaggle probably you would have just 10 data sets where you're using the machine learning algorithm, but in real life, in some of our client engagement, we have thousands of data sets, right? So it is very crucial that you kind of automate the data preparation kind of phase where you're automating the data ingestion. Right, so one of the, as in the same kind of client engagement, we had pretty much ingested 500,000 data sources. I should not say data sources, but data columns onto a data platform, right? So that's a huge deal, and that's the data kind of level or the data gamut that we are talking about, right, in the real life. So having said that, so augmented data preparation is what the industry is looking at to solve the data preparation problem that we have for any data analytics or a big data project. And that is kind of, these are the Gartner's top 10 data and analytics trend for 2020. And, if you look at the top two trends, it's talk about augmented analytics and augmented data management. So essentially, what is augmented data management and augmented data preparation? This capability helps enterprise to build the modern data platform. Most of the time, the modern data platform is built on cloud, essentially because you get the scalability of cloud, right? I mean, you're not restricted by, if you are on cloud, you're not restricted by the size, like the storage. Also, you're not restricted by the computing power of any infrastructure. In cloud, you pretty much can kind of increase or decrease. So you get the scalability onto the cloud. So that's why the industry is going towards modern data platform, using augmented data preparation and creating this augmented data management, right? The other thing is, like, once the modern data platform are pretty much governed, like, the data lineage, where it came from, when was it refreshed, you kind of know who uses it, as I said before in my previous slide, that is done by data fingerprinting, data tagging, right, all those stuff. So together, we kind of are creating a governed data lake, and that's the modern data platform. Also, for example, in a modern data platform, the data is pretty much searchable. Say, for example, I'll give you an example. If a data scientist kind of looking for, where to find all the data that talks about a demographic of a customer. So how would a data scientist team know where to find the data if he has to answer this question? But if you have a searchable data platform, that can be easily done. The modern data platform, one of the features or capability of a modern data platform is searchable, right? So that kind of helps the data scientist. So, I won't go in any of this specific deeply because it's too technical, and, with the time constraint, I would just like to kind of give you a flavor as to what data engineering is and what augmented data preparation is, and what does modern data platform look like, right? So this is where I'll stop. And the next thing I wanted to talk about was, most of the times when I interact with the business school students, one of the questions I get very often is, where do we start the careers or journey in a deep tech company like ours? And I'll just spend 5 minutes on that, right, answering that question, and of course I'll be answering any questions that you have post my talk. So this is a slide that I've got from Glassdoor. So you would be surprised to see that any tech company, 43% jobs are non-tech jobs, right? And I'm not saying that you guys cannot go in a hardcore tech job. I mean, if you love coding, as Dheeraj rightly said, you have to love coding, and you have to be very good at it if you want to have a tech job, right? But having said so, what I'm coming to is like even a deep tech company like ours, almost I would say 50% jobs are non-tech, and I'll just touch upon where all we need talent like the business school, like your school, right? So say, for example, I'm building a product around data. So who would all I need? I would need a product manager who understands the big data kind of ecosystem, who understands the data flow, who understands the whole ecosystem, right? So we would need a product manager who kind of understands that and we don't expect him to code, but he has to kind of understand the principles of big data ecosystem, right? So same. Then we need UX guys who are user experience, who can kind of refine the product with a user experience kind of thing in mind. We also need scrum masters. We need project managers. We need business analysts who kind of are able to take the requirements from the client, from the industry, from the research, and kind of give those back to the technical team so that they can kind of get the requirements and design the solution around it. Also, who else would I need? I would need a BA, product manager, product owner, and one of the things happening in the industry is like in the delivery pillar, everything is agile. So we have in a client engagement as well, we have a lot of small teams which work on agile. So there is always in every team, we need product owner, we need project managers, we need scrum masters, we need quality assurance manager, and of course delivery manager, which comes at a higher level. I mean, once you kind of are in the industry for 10-15 years, you kind of get there. But having said so, all these jobs are kind of non-tech jobs, and I've listed a couple of them. Obviously, I will not go through each one of that, but then all these, like one of the examples from sales and marketing I will take is technical content writer. Now, if you have a flair for writing and also understand technology, you could be a very good technical writer. And the enterprises like us or across the industry need very, very good technical content writer. So what I'm getting to is it's not that you just have to go after the tech jobs. Of course, they are very glitzy, and if you love programming, please go ahead and go for it. And I'm not saying that you cannot get into it, but I'm just kind of giving you a perspective that a deep tech company like ours also kind of need non-tech kind of talent. And essentially, when we go and recruit in a lot of MBA schools, we are kind of looking at all these positions. So this is just to give you a perspective as to what the enterprise or what the industry is looking at from the academia. So this is all I had to say, Ms. Lakshmi, and I'll be open to any questions. That's it.
Thank you so much, Aarti. You did a deep dive into the length and breadth of this entire space of, I should not call it as a data science, but analytics space is what you have done. So you have spoken about why students or the upcoming, the young freshers who get into this industry should focus on data preparation, so which is very significant. And you have spoken about augmented data preparation and capability. I'm sure students are having questions on that. And automated data pipelines and as well as data tagging. I found it very interesting. And how are you going to build those forms and all those new words which has come out from me? I think we can expect a lot of questions from our students. So we'll go to the next speaker, Aarti, and we'll come back to you with our questions. Thanks very much for your wonderful talk.
My pleasure.
So audience, so we are going to move on to the next speaker, Nishant Saxena, from Dell EMC. So I'm going to speak about what Dell EMC is doing in the space of analytics, and we'll have an introduction about Nishant himself. So Dell EMC Ready Solutions for Data Analytics, it provides an end-to-end portfolio of predefined, integrated, and validated tools for big data analytics. So it consists of high-performance Dell EMC infrastructure. And so here, so we always knew Dell EMC as a more of a hardware company. And so what we are doing in the analytics space, to speak about that, we have Nishant Saxena here. So Nishant leads the modern cloud and application services India technical delivery portfolio for Dell technology-enabled services. So he's been with the Dell for more than 2 years now. Prior to this, Nishant has 14 years of experience leading analytics delivery for HPE, Honeywell Global Marketing, and Cognizant Business Consulting. Nishant has one HPE patent published, and he has 2 articles on pre-sales analytics published in international academic journals. And he has evangelized business analytics in a dozen international conferences. So he has got a BE from VTU, and he has got an MBA in finance from IBS Hyderabad. We have the pleasure of welcoming you, Nishant, and we are heartily welcome you to this session. And we expect you to speak on the topic demystifying data science and whatever the insights you want to throw to our students on this, the most happening space. Over to you, Nishant.
Thank you, Professor Lakshmi. Am I audible?
Yes, you are audible.
All right. So to begin with, first of all, I would like to thank everyone. I was really kind of impressed to see that during this tough time, it's not just the education which is continuing. People are still taking time to do these conferences and put all the efforts to make sure the learning never goes anywhere else. So thanks a lot. That was really interesting. Is my screen visible to all of you?
Yes, Nishant.
All right. So demystifying data science. So we heard a lot about data science, data being science, or whether we should call it data science or arts, or how things are changing and how instead of data scientists being called upon now it's turned for data engineers. So it's really interesting to see all that. And let me start from the beginning. So one question which keeps coming to everybody's mind is, what essentially is data science? So to give you an example, so for example, if you see that identifying those variables and matrices that might be better predictors of performance. So this is one particular example that in terms of athletics versus Yankees, where do we have cost per win higher? So somebody might be winning a lot of teams, but what does it cost to make the win? So that is one example of data science. So to quote another example from your own life, so a typical example would be before you started your MBA career, you must be thinking about whether I should take a specialization in analytics or finance or marketing or HR or whatnot. So at that point of time, just go back to the memory lane and think, what is that you are doing? You are trying to find out from your friends, where will I have a better career? You would be doing some primary research, you'll be doing some secondary research, you will be searching a lot of reviews and ratings and career opportunities on Google. After doing all that, you reach the decision that, okay, this is what seems like the best decision to take at this point of time. I'm going to choose a career in MBA and a specialization in analytics. So that's a typical example of what data science does. If there was a portal, imagine there was a portal or tool available which can tell you exactly the kind of future that you're going to have if you chose a specialization in data science or analytics vis-a-vis say marketing or finance. If there was a portal to tell you exactly which school, which year, what you need to do, your life would have been so easy. So that's exactly what data science is all about, trying to help people take decisions which are better, to help them in taking informed decisions. So at any point of time, anybody can take a decision. What matters is how much confidence do you have in the decision which you take, whether it will be the right decision for you or not. So that is the core to the data science. So the point here again is when you look at what is data science, the example, it all is subjective. So is this all data science? No, it depends on what exactly the person analyzing the data wants to find out. If for him money is the most important factor, that what would it cost me to secure n number of wins, this is what he should look at. So let's move on. All right. So now that we are talking about demystifying data science. So as you know, science is all about processes. So it has to be done in a specific way, in a specific order to make sure that whatever the outcome is really going to help you and it is really useful. So a lot of people can do a lot of analysis and a lot of outputs can come. What will give you the assurance that the outcome is the best possible outcome at any point of time? There is never a certainty or never a surety. You can never be 100% accurate. You try to be as close to 100% as possible. And if you are following a laid down and tested approach to solving a business problem, you are always going to get two values out of it. Number one, the biggest value is that you will be closest possible to 100% accuracy. And the second the value add which generally people forget is the time saving. At any point of time, it's not about just the right decision, it's taking the right decision at the right time. So the time that you invest in taking a decision always matters a lot. And that is one of the most important factors. So if I were to go from, say, if I'm living in Bangalore, I wanted to go from Mahadevpura to, say, for example, Silk Board. There are 100 number of routes which I can take to reach there. But at any point of time, if I decided randomly that I'll start walking north, then again I'll do correction, walk south, take east, take west. Finally, someday I'm definitely going to reach Silk Board. But what would I rather do at this point in time? I'll open Google Map, not just see the shortest possible route, but also see the shortest possible route based on traffic congestion, and then decide that this is the right route to take. This is how I can reach there faster. Whether I'll reach or not, there is no 100% guarantee. Things can change at any point of time, as we were all talking about VUCA world. But I have taken the right decision with the confidence that, yeah, this is the best thing that I can do at this point of time, given the limitations of all the resources that I have. And so for that purpose, I just wanted to highlight that at any point of time, you need to follow a process. First of all, this is one thing which we all learn, but essentially most of the people don't do it in real time. So if I talk about industry, I see so many data scientists working. Some of them are just lost in the codes that they are writing. Some of them are lost in some algorithms. Some of them are lost somewhere else, that there is no data, how to fix the data, as data engineering talks were going on. End of the day, people generally lose track over a period of time of what they were originally planning to do. So it's very important to define a hypothesis or understand the business problem and keep remembering it throughout your analysis phase. So define hypothesis, then gather data. As everybody is talking, data is the most critical thing. Prepare data. So at any point of time, you can collect a lot of data, but it could become garbage in, garbage out. So make sure you prepare the data, do all the tweakings necessary, whether it's data imputation or whatever, to get to use the right data. Then visualize the data. It's more of assurance. Sometimes the right visualization tool can give you a lot of insight on their own. Then build any analytics model. And finally, evaluate the model for the goodness of it, whether I have come to the result which I wanted to or not, and then repeat. So this process goes on like any experiment that you do in science. Things can change, but the basics remains the same. So that's why it's very important to remember this process. We all study this in school, but the moment we go to industry, we tend to forget it. So next, have a quick look at evaluation of analytics. So analytics, as data has always been there, as you were listening from the previous speaker, that from time immemorial, like if you go back to hundreds or thousands of years, data was always there. Things have tried to evolve, And most of the time when it comes to industry, analytics is mostly limited to what people think of as business intelligence. That I have the historical data, this is what happened in past, this is how I look at it. Based on that, this is what I'm going to do in future. So the movement away from business intelligence at any point of time, business intelligence is always good. You definitely need to know why my sales is going down, why my profit is down, what can I do to increase it. But at the same time, you have to step up the game and look into data science, which is more one step further about how you can predict the future and how you can lay the right course. So talking about laying the right course, this is how the analytics have evolved over a period of time from something what we call as descriptive analytics, talking about what happened. Of course, it adds value to predictive analytics, talking about what is likely to happen, and finally to prescriptive analytics, what should we do? So at any point of time, as you heard from our esteemed speaker, that you should always know how to tell a story. If you go and tell your boss that, okay, I looked into the data, this is my finding, he may like it, but end of the day, his boss may not like it or his boss may not like it. So you always have to build a story that originally this was the problem. These were the various possibilities based on all the available data. These are the various outcomes of those possibilities, and based on applying the right analytics, I suggest this is the course you should take. So at any point of time, always keep in mind that those sitting at top will not be understanding your complex, most of the time in general, will not be understanding your complex neural network algorithms or random forest, or if you go and talk to them about 3 sigma or 2 sigma and things like that, they may not understand. They just understand the simple English. You need to tell them this is your business problem and this is what I'm going to do to solve it. So you have to become a storyteller. That would be your key to success in industry, with lots of knowledge of theory and lots of knowledge of right algorithm and right tools and things like that. I'll come to tool in a moment. You can always enter into a IT industry or any industry for the matter. But if you want to grow in your career, you need to understand things end to end. You need to understand the business need. You should not be limiting yourselves to the algorithms or to the programming languages. That will take you far and that will speeden up the process of your career growth. So again, some example of how business intelligence is different from data science, more of retrospective versus forward looking. And finally, just give me a moment. Yeah, so some common data science techniques. So this is where I just wanted to talk a bit about the tools and techniques. So at any point of time, my recommendation to all the people who I select from various MBA schools or wherever I go and talk, I say few things. Number one, always make sure that your basics are strong. Unless and until you have a full command on the fundamentals, you will never be able to succeed in life. Most of the people do some advanced course. Right now, some tool is burning in the market. You just learned it. Because of that, you got a job, but it won't be sustainable. Because the rate at which technology is changing, by the time you become a specialist in some technology, that technology would be out of the market. But as long as you understand the fundamentals, you will always be strong. Now the question comes, what fundamentals? Number one for analytics is you need to know the basics of mathematics. And even before that, the few basic things, you should always ask questions. So what, why, where, when, why this way and not that way, as long as you are curious and you are not shy of asking questions. So this is one thing which I generally see in industries when you are talking to people from different countries. When you are considered to be a data scientist or senior data scientist, you are always shy. What if I ask this question? People might start laughing or they will think I'm fool. Don't be shy. A question is never wrong. Feel free to ask any stupid questions. Those are the things which will really make you successful. So have this curiosity that I want to know why, when, where, how, why this way and not that way. As long as you are walking on the streets and always analyzing, okay, if there's something happened, why it happened. So it has to go in your subconscious mind. If your subconscious mind is trained to ask questions, you will be a very successful data scientist, data engineer, or whatnot. Number two, the basics of whatever you learned, mathematics and science in school. Make sure that your fundamentals are strong, especially if you have an engineering background. People nowadays talk about so many programming languages. Python and R is really burning hard in the market. The time when I studied C, C++. But end of the day, if I really studied even C properly or C++ properly, as long as I understand the basics of algorithm, how things move in a proper way, what are the basic constructs of any programming language. End of the day, a programming language is an interface between a human and a computer. As long as you understand the basics of computers, what works, there are only 4 or 5 basic things. There has to be a storage, there has to be a CPU, there has to be a tool to monitor the output, and there has to be some kind of networking setup and all that. So as long as you understand the basics, things may change. Things may move from those large servers to the cloud, but end of the day, the basics remains the same. There has to be a storage for cloud also, whether it is software defined or whether the networking is software defined or whether it is physical. End of the day, there has to be some networking. So as long as your basics are strong, whatever new things come up in the market, you can always quickly learn it. Any language change, if you learned one language properly, if you really did it once in your lifetime, you can grasp any new language in just a matter of 1 or 2 months. So that will always keep you going. And then always remember that there might be hundreds of tools in the market, but end of the day, you need to know few basic tools. Why? Because supposing that you want to cut a tree, so you might be having hundreds of tools in your arena that, okay, there is 100 types of screwdrivers, 100 types of hammers, 100 types of choppers and things like that, but you can't cut a tree with a hammer. You need to have an axe to cut a tree. So axe could be hundreds of types. End of the day, as long as you know that I need an axe to cut a tree and I need a hammer to nail, you are good. Things will change. There might be 10-20% variation in the tools that you see in the market, but as long as you understand that there always has to be a core called a storage or a database where all the data would be stored. If you're talking about data science, there has to be some place where I'm going to keep all the data. So as long as you understand the basics of a database, you are good. Database could be hundreds of types, whether you are RDBMS or whether you are moving to something on Hadoop schema. Doesn't matter, as long as you understand. Next is there has to be a tool to ingest the data in the database. So as long as you understand some basic tools which you can use to ingest various types of data, whether you are ingesting data from a streaming media or whether you are ingesting data into a database from another database, as long as you understand that there has to be some basic data ingestion tools, you are good there. Then there has to be some tool to extract the data from the database. You need to learn few of the tools that, okay, these are the tools I can use. Then there has to be some staging area where you will do all your data manipulation, data preparation, whether you want to add the missing value, whether you want to convert rows to columns or do whatever. So learn few tools which will help you in that. Once you are ready with the data, then you need to have just few tools ready to do the analysis on that. So at any point of time, if a business is there, you should be able to understand the difference between a cluster analysis and a decision tree. So at any point of time, based on the business need, you need to know some of the basic techniques that, okay, these are the things which are going to help, and that is all you need to know. After that, if you learned on top of it some visualization tools to represent your output better, because that is why it is going to get you buy-ins from your leaders, you are good. So end of the day, don't get confused about what tools to study, what not to. Make sure your basics are right. Focus more on learning the behavior in your MBA school. In an MBA school, you are not going to become a, say, regression expert or a data a neural network expert or a deep learning expert. For that, there are different places. End of the day, what you need to understand here is tomorrow when you join industry, you would be the bridge between a business leader and a technical guy. And as long as you focus on 360-degree learning, understanding the business and understanding at high levels the basic of the technology, you will always succeed in life. That's all I wanted to say today. Thank you very much.
Thank you so much, Nishant. I think your advice to our students is really valuable, and we appreciate that, Nishant, so much. And so, Aarti and Nishant, so we have loads of questions for you from our students. At the Q&A, I've compiled a few of them, and so I will be directing the question very specifically to the speaker as the students had asked for, based on the talk which you have given. So. Yeah, to start with the question here, goes to Aarti. So how is data engineering different from data science? He's a student who is not selected any specialization. He's a first year MBA student. So Ankit wants to know where to start for a first year student, because he's comfortable only with statistics, but he's got, he likes, he's passionate towards analytics. So how would you guide them, Aarti?
So essentially, the difference between a data engineer and a data science. So a data science is kind of, you have to know, as he has rightly mentioned, you have to have your math concept very clear, like a stats, like you have to have a stats background, a coding background, and then some functional. I mean, you at the end of the day, you have to understand business. But having said so, and then coming to data engineering, I mean, it's a pure play kind of a coding kind of a skill, right? A data engineer, essentially day in and day out, they need to code. And if you want to kind of go into the data engineering path, what I would suggest, I mean, as Nishant has rightly said, I mean, get your basics right. Dheeraj also said, get your basics right. So for data engineering kind of, stream, what I would suggest, I mean, first, I mean, yeah, it would sound very ridiculous, but, you have to be extremely good in SQL. I mean, and not just, simple SQL, advanced level SQL, because believe it or not, that's the skill that most of the time data engineers use. So I would say be very good at SQL if you want to come into data engineering. Probably know some scripting language. Maybe Perl or maybe Python. Python has a lot of libraries nowadays. So Python is a good start. And then the third thing would be, know a coding language. Again, Python, Java, nowadays Scala. I mean, if you are good at Java, good at coding, I would suggest take on Scala. And the other skills like, soft skills, like communication skills, and I think that those would be common across kind of any role. So these are something that I would like to put forward.
Yeah, thanks, Aarti. So Nishant, you have a question from Keerti. Any words of wisdom for data science students who are starting out fresh, and especially from an MBA background?
Yep, so as I just mentioned, especially for those who are starting out fresh, don't get lost in the productized world. Right now, you will see so many products, so many tools, technologies. You will be totally lost if you started thinking whether I should learn Microsoft, whether I should go to AWS, whether I should use SaaS, whether I should use this tool. Don't get bogged down by that. If your basics are already strong, the easiest way to learn a tool is first categorize that, okay, these are the 5, 6 things I need to know. One, two tools more than enough. Go to Google, put a technology. You want to say, for example, just now, the other lady was talking about SQL. So end of the day, if you want to extract data, what is the most commonly used data extraction tool? Whatever comes in the first page of Google, first 1 or 2, just learn that. If you learned 6, 7 key segments, you are good to go. Don't get bogged down. I want to learn the best tool in the market. I want to learn the best book in the market. End of the day, the difference will be only 10, 20%. If you have a guide who can tell you this is the best to choose, which I'm sure Professor Lakshmi you are there to do, even if not, just learn the basics, that would do. So the best thing I would say is don't get lost in the options. It's like if you started thinking too much about which car to buy, you will never buy a car. And by the time you bought a car, that car would be obsolete and you will be regretting why I bought this. So time is the key. Learn as much as you can. Don't think about the best or the topmost.
Thank you. Okay. Yeah, so I think the discussion is really going with the right direction. So I have a couple of more questions in a slightly different line. So Aarti, you've been a co-founder in Modak. So I also want to know why the name Modak and what does it mean? We all know only one Modak for Lord Ganesha. And what is why the name Modak?
Well, yeah, I named it Modak. I mean, essentially, I mean, I'm from the city of Pune. I mean, graduated from Pune University, and essentially, my idea of naming it Modak was, Modak, as we call it in Marathi. It's a fruit of all your hard work, or it's a fruit of your sadhana. That's what it represents. So at Modak, we kind of get insight. We kind of, mine data and get insight into your data, and that's the fruit of the whole sadhana that the enterprise has done.
Okay, there is a story behind it. Okay.
Yeah, that was
We
my
all
kind
believe in. So I'm sure your organization has rolled out multiple projects as part of your growth in the past 10 years. So what do you think is the greatest challenge in any particular project which you have handled while you handed it over to your client? Any challenging project you came across, you were handling, and how did you overcome it? Yeah, this question is, by the way, from one of our students, Joseph.
Joseph, yeah. So hi, Joseph. So so as I said, we handle huge projects where we are dealing with petabytes of data, and for enterprise, a deep tech company like us, we have to essentially show value at the end of the day. And so one of the challenges is how quickly are we able to get the data platform up and running? So one of their clients, it's in life sciences, and usually it would have taken a couple of years, a year or two, for them to kind of bring the platform up and ingest the data, curate the data, cleanse the data, and get it together. And using Nabu, which is our flagship product, we got that platform up and running in 3 months. So I would say the main challenge that we come across is that we have to kind of show business value in whatever we do and whatever we deliver. So I think that's the kind of challenge at Modak that we have. I won't say challenge, but exciting thing that how quickly we kind of show value to the client. And having said so, once he said challenging, but I would also like to put in right now we are working on a life sciences domain. And it's so exciting because there is a lot of stuff that is happening in life science. I mean, and there's never been a good time with I shouldn't say a good time with pandemic. I mean, we are looking at life sciences and pharma companies when they are going to come with the vaccine. And essentially, if a pharma company is looking at data to solve any of their problems, how fantastic would it be? I mean, as an engineer, as a kind of data science, data analytics company, how fantastic would it be that you do not have a core competency in pharmaceutical per se, but you're still able to assist the company to come up with drug. And I think that's the most satisfying kind of part of our job at Modak.
Yeah, so you can also highlight our students about the NDAs and the data, especially in the life sciences and this area about the data privacy. You want to speak on that?
Yeah, sure. So data privacy, I mean, not just for Modak, for everybody. I mean, it's paramount. But having said so, we do not kind of host any of the client data. I mean, the infrastructure is at the client location or is at the cloud, but essentially it's a secure cloud. So we just use their infrastructure, their data to kind of, ingest and come up with the platform. So, NDAs, I mean, those are there not only for Modak, but I think that those are there across the industry for everybody, that has. I mean, even we have NDAs for our vendors, I mean, the vendors that we work with, right? So that's, I think, a norm. in the industry. But having said so, data security, I mean, yeah, I mean, big enterprises, because we work with, Fortune 100 companies, and they have excellent data security measures, right? So we don't have to worry about it, thankfully. I mean, it's just their data infrastructure, their data, and their security. We just kind of, work with the whole ecosystem of theirs.
Right, yeah. So Nishant, I want to hear it out from you. Any challenges when you were working on any deployment models?
So related to data security or in general?
No, in general. I mean, the first question which I was
Yeah.
asking, Aarti, your
Okay.
experience.
So as Aarti correctly mentioned, at any point of time is the business value which is most important. As I said, end of the day, you can do hundreds of things, but the person who is giving money, who is going to take business decision, he is just looking at one thing. I invest X amount of dollar. What is the value I am going to get out of it? And why I emphasize on business value is because for rest of the things, you can easily give business value. You gave me investment of these many tools in my manufacturing plant. I'm going to give you business value in terms of these many products. Earlier it used to be say 20 cars per month. Now I'm going to produce 25 car per month. But when it comes to analytics, there is a lot of subjectivity. So business value in terms of analytics is always complex. So you have to come up with precise measures that, okay, whether it is in time saving, whether it is in dollar saving, whether it is short-term business value, whether it is long-term business value. So a lot of emphasis has to be put on making sure that you really understand the customer's demand and accordingly provide him the business value. Because end of the day, if he gave you the money and if you are not going to show him the business value, it is going to be a disaster. And one more point there is business values are always perceived. So it's one thing for you to understand that, okay, this is a great business value, but is your customer or the person in front perceiving it the same way? So you have to put the effort to make him understand what you think his value is actually value for us.
That's right. Yes. Yes. Thanks.
Yep.
Thanks, Nishant. Yeah, business value, that value proposition is something, all of us need to understand and appreciate from the business side, whatever we do. So we have a question from our one of our alumni, Venkatraman, who is in the space of analytics. He's already working there. So his question is, how difficult is to find the product market fit in the data engineering and data science space? I'm reading out the question. Aarti, the question is for you. And
Okay.
what strategies Modak adopts to find the product market fit?
Well, we have a product. I mean, that's a good question. I mean, I mean, before Nabu, I mean, it's not that Nabu has been our first product, right? I mean, I would be lying. I mean, I've been doing this for, I mean, I've been entrepreneur for the last 10 years, and believe it or not, I've, learned everything the hard way. So, I understand where the question is coming from. So, Nabu is not kind of our first product, but what I'm product market fit is the question. So, what I would like to do is, you have to have your eyes and ears open as to what problem the industry is facing. Right? I mean, see, at the end of the day, there has to be a need in the market for the product. Right? So, don't start with developing a product and then go to the market and find a fit where there is a product market fit. It has to be other way around, right? I mean, there has to be a problem in the market, in the industry, and then that is something that you kind of have to solve. And the other thing I would say is, like, one of the mistakes that a lot of product companies make is, like, they develop a full-fledged product, and then they, kind of present or, as a, sample, and then they realize, there has to be some changes. So that's not the way to go. You have to kind of develop a MVP, that is a minimum viable product, and then kind of, give it to some of, what would I say, a researcher or something who would try your products and give you feedback. And then, take those feedback and then kind of develop it into, a more sophisticated or a more kind of finesse product is what I would get to. And then being in the product space, I mean, there is always some refinement that you would do to the product. I mean, even if a product is deployed at a client location, there are so many feedbacks. I mean, some clients like it this way, and there are feedbacks coming in. So, you have to have a kind of a dedicated development team, which is kind of taking the feedback from the market and kind of, maybe you can, you can go to market with a different version or patches or something. But having said so, there has to be a development team which is kind of listening to the market, taking the feedback, and then incorporating at least some of them into the product. So I would say product market fit, yeah, it's a very difficult kind of thing, and you have to really walk the fine line, if you will, because at the end of the day, I mean, you're answerable to your board as well. So it's a very fine line that you have to walk. I hope I answered the question.
Yeah. Yes, yeah. So good perspective, Aarti. So I have a question to you about so much you have invested in the data infrastructure. That is, when you spoke about data lakes, and but you still keep talking about it. You in your presentation you spoke about 80% of the time is spent on data preparation. Because again, one of our students has highlighted, Aditya has highlighted this idea and asking you, why so much I'm spending on IT, technology, infrastructure, and all of that, still why we are not automating certain processes? How do you carry this forward in Modak when you're actually working on data?
Yes, I mean, yeah, that's a good point. I mean, that's what we did. So data preparation is a big problem, and then part of it has to do with the data quality, and the data is sitting in silos across the enterprise, right? I mean, and there is some standardization, but that data is not standard because data has been lying and growing in those silos for so many years, decades. So to answer the question of Mr. Aditya, why don't we use automation there? Yes, we are using automation in data preparation, and that's using Nabu. I mean, Nabu is a product which is kind of we have a lot of IP there where we are automating the data preparation and the data ingestion and a lot of other stuff, but essentially the data preparation, and that's why we use Nabu, and we are able to kind of reduce the data preparation time taken for data preparation, and and then bring more value, time to value for the business. So because since the data preparation time is reduced, obviously we would get the value to the business, the spend, the ROI on the data infrastructure faster to the business.
Yeah, that's right. Yeah. So thanks, Aarti. So we have multiple questions after Aarti's presentation on the job market and other things. So I'll just direct this question to Nishank. So what is the background of students who should opt for this? As Harvard Business Review quoted, the sexiest job of the 21st century. I think since that time, I think most of the general public got excited. Everyone starts thinking, why I should not look at DS or a data science as an option. I think everybody wants to jump into this and find out, what is out there. So what is, and Dheeraj was talking about that the poets, programmers, and poets and other people. So what are the background, right background anybody should come from in order to get into this space? Or is there any? Of course, we know every other domain analytics is being applied nowadays, and it's a lot more things are coming up in the future as well. But looking from our students' perspective, Nishant, so can you advise our students and advising them whether, because they're going to choose their specialization, should engineers only will make that cut, or somebody from mathematics background could do that, or somebody from statistics background, all the varied kind of this. This is a pertinent question for our students. Can you help them understand this, Nishank?
Sure. So let me think and answer this question from a recruiter's perspective. So whenever I go to the MBA colleges or I go out hiring, what would I look at? So the ideal candidate would be, if you see at a high level, the ideal candidate would be someone with a computer science background plus someone who has done MBA. So somebody who has done computer science engineering or information science engineering and MBA, or depending upon my need, if I'm looking for say, a typical statistician in my uh, say job role, then I may go to a college like an ISI for hiring like top statisticians. So essentially, if you have a computer science engineering background and why MBA on top of it, it is something like arts and science. So when you learn analytics, you should learn it as a science. When you apply it as an arts. So when as long as you're learning, it is science. The moment you started thinking beyond boundaries, it becomes arts. So MBA is something like that. You learn something in your engineering college that, okay, this is what I need to do, and then you're doing, understanding how to relate that to business. But end of the day, even then, the core thing that I would still look for is two. Number one, how strong is your fundamentals? So as long as you have strong fundamentals, and number two, how many questions you can ask. So at any point of time, you might be having a lot of knowledge, but in a critical customer discussion or when some escalation is happening, if you don't know what to ask, and if you're shy of asking question, you won't be able to do it. So even if you do not have a computer science engineering background, don't get disheartened. As long as you have this in you that, yeah, I am not shy of asking any questions, and I'm very sure that my fundamentals are strong, you can definitely have a career in data science space. And talking about the buzzword in the industry, data scientists. So again, guys, today, as RP already, sorry, as RP already suggested, that data engineering is a top data scientist now in the list. You never know, you will take 2 years to complete your MBA course, something else might be there at that point of time. So don't bother about the title. The job title is not important. I might be the CEO of a company, but I might be getting salary less than senior manager who is getting in another company. So end of the day, you need to see that where is the money, and of course to satisfy your egoistic need that I want to be called a data scientist. Great, that's fine. What I wanted to say is focus more on learning right now. The moment you start looking for job, then bother about the title.
Yeah, that's a great piece of advice, Nishant, and we keep saying that to our students as well. So loads of questions coming up, but I have one question. I think both of you can take it up. Any one of you can take it up. So HR analytics, or how analytics could be used in identify human behavior, or it's a measure human behavior, because I see that even when Dheeraj was talking, he was talking about every other domain coming into this space. I think psychology is something in a team of data scientists or a group in a project. I think the behavioral aspect of a consumer also should be taken into consideration when you are building those models. So what is the influence of analytics on behavior, behavioral sciences?
If I may. So
Yes.
one of the examples I will give you from the typical industry or challenge that I face a day to day on a day to basis is human error. So is I work for delivery and I take care of cloud analytics and such kind of delivery, and we always encounter once in a while some human error. And the answer is, as long as humans are there, human error would be there. No. So at that point of time, something like an HR analytics would be really very useful. So if I started looking from the perspective of the person who did this error, why that error happened, what was the state of mind of that person? Was he overworked? Was he overconfident? Was he not doing his job properly before this error happened? So at any point of time, you need to understand the psyche and behavior of your employees or all your customer. So at any point of time, if a human error happened or something went wrong, I cannot fire all my employees or the person who did it likewise. So when you have this limitation that, okay, these are the people and you have to make sure that they give the best to you. So you need to understand what demotivates them, what motivates them, what will bring them to office, or nowadays whether working from home, what would keep them in the best state of their mind. So those all things would be possible only when you understand it from a human resources perspective, that what is that person going through, what is his background, what is the thinking and things like that. And that is where analytics, HR analytics has a huge role to play. So HR analytics is also very important. Even when you go to hiring, that I need to hire, there are so many CVs available in the market, and all of them seem to possess the right quality in terms of educational background or say experience, whom to choose. That is when you want to choose a person with the right attitude, with the right mindset, with lot of positive energy, because end of the day all of them are technicians. There are 10 different guys with same knowledge, same background, and same experience. Who will I choose? I will choose the person with the right attitude, which is most important. Because if I miss there, I might hire a IITN with IM background, and he might not be. He would be very reluctant to do the work. Oh, yeah, I am from IIT, IM background. Why do you want me to do this work? I'm not going to do it. I will tell others how to do it. So attitude is very important. So that way, HR analytics has a huge role to play.
Yeah, Aarti, you want to add on to this?
Yeah, I mean, since Nishant has answered on HR analytics, I'll just answer the other question, the psychology. I mean, where do psychologists kind of fit into something like, data analytics, data science, and a deep tech company like us? I'll give you an example of a product. So if you are developing a product for a certain age group, and I think the essential kind of example that everybody would understand, like a WhatsApp and a Snapchat. I mean, the audience is so different. I mean, WhatsApp, yes, it's for everybody, but the Snapchat, I would say the age group is between 18 to 25 or 30. I mean, I don't use Snapchat, my teenagers use one. I don't know the age group, but that's the group that they are using. So a psychologist, if you have a psychologist in team, that would be a great value add where when we are designing a product, because we need to have a kind of a different perspective, because at the end of the day, even if we design a product, it is being used by a number of people across, across sections of society. So it is going to be very helpful to have a psychologist in the team so that, we understand the whole consumers better, is what I would say. And it's just an example of product. That's true with everything for analytics. I mean, even if I take an example in BFI sector, it's always helpful to have a psychologist in the team who would kind of understand what products to pitch in, and how do you kind of connect with the customer, what messaging do you give. So yes, to answer the question, yes, we need all sort of people in the industry, even if it is a deep tech space.
Yeah, that's a valuable answer, because given the fact that you work in the micro segment as well, micro target customer, I'm sure you are actually working at the granular level as well.
Absolutely.
Yeah. So 1 hour and almost close to 2 hours, and I see the audience just hooked up to the session. Really amazing. And thank you so much, Aarti and Nishant, for being part of this panel discussion, and the team Demystifying Data Science. Appreciating your time and presence here, and each of your comments which you have brought through here is going to be a good insight for our students, and it's going to definitely change their lives forever as they are working on building a career in the data science. Thank you so much for accepting our invite. And on behalf of Christ University, in specific from School of Business and Management, I thank both of you for your presence and the contribution to this panel discussion. Thank you.
Thank you. It was a pleasure. Yeah. And I wish you all the best.
Yeah.
All of you.
And just a formal word of thanks from my side for the university. So on behalf of the entire team of Business Analytics Specialization faculty team, we would like to thank the management of Christ University, our Dean, Dr. Jane Matthew, our Associate Dean, Dr. Georgie Kurian, who has given the welcome address at the beginning, and all our leadership team of School of Business and Management, and our audience comprising of business analytics students, the seniors, and a prospective students, that's the one who have just taken the 2022 batch, who are looking forward for taking this as a specialization in the coming months, and our alumni who are very much present here, and the organizing team of the symposium, and most importantly, Mr. Jose Martin, who has been meticulous in ensuring that the event is conducted in an impeccable manner. And so thank you again for Aarti and Nishant. Aarti, you really gave those technical aspects to our students. I think they're going to bombard all the faculty with a lot of questions. I think we also need to be prepared with all those things, because we also learned a lot, and we also know which direction we need to take our students towards, because if we also teach, we don't focus so much on tools, but definitely tools are also part of their curriculum. R, SQL, Python, Tableau, all of that is part of the curriculum, but your talk has given them good insight as to where they need to focus on. Nishant, your conceptual clarity which you gave to our students is definitely reiterating the fact that whatever we have been speaking about in our data science classes. Thank you so much. Thanks everybody for your presence. See you all tomorrow. We have one more day, second event. So tomorrow's session is on applications of analytics in businesses. See you all.
Thank you, ma'am.
Thank you.
Thanks, everyone.
Thank you.
Good night.
Thank you.